So we will start with OOPS, that is nothing but object oriented programming. So before going to OOPS, we will discuss the difference between Verilog and system Verilog. So in Verilog we have module and end module. Let's say if we declare any register, say reg A or reg B, or if we declare any integer int I or int m. Yeah. So in module, when we declare any registers reg A, reg B, or int I, int m, so all these variables can store the value. Say suppose A is equal to 0 or A is equal to 1 or m is equal to 3, like this. So all these variables can store this value, and this value is stored in some particular memory location inside the memory. So these values are stored. So for these variables, say suppose for this register a memory location will be created, and at some address the value will be stored for this register A. So this register A will be stored in a particular memory location. So once when the variable is created, then a memory location for this variable is created. So when a variable is declared, then the memory will be created for that particular variable, and the value when we store into this variable will be stored into this particular memory. And when we assign any other value to this variable, then this value will be stored in the same memory location, overriding the previous value. So for every time, so when every time when we try to store this value into this variable, it will be stored into the same memory location by overriding the previous values. So this is called static memory allocation. Static memory allocation. So every time when we try to store the values into our registers or integers, so the value will be get stored into some memory location by overriding the previous values. By so every time only one memory location will be created for this variables when we try to store the value into this variables. So is it clear for everyone? This is called statically allocating or static memory allocation. Is it clear?
Exactly.
Yeah. So now let's discuss some basic terminologies in OOPS, and we will come back to this static and dynamic memory allocations. So there are some basic terminologies in OOPS. The first terminology is called class, and another is called object and handle, and we have property and a method. So these are some of the terms which are used in OOPS: class, object, handle, property, and method. So we will discuss one by one. First one is class. So a class is nothing but a basic building block. So a class is nothing but a basic building block containing routines and variables. This is analogous to module in a Verilog. This is similar to module in Verilog. Not exactly, but it is very similar to module in a Verilog. In Verilog also, module is a basic building block, and here in SV, in OOPS, class is also a basic building block. So if we want to write anything in Verilog, we will write it in module. Here the same, it is also a class is also a basic building block. It is like a blueprint. And coming to object, it is similar to instant. So basically an object is an instance of a class. Like Basically, object is an instance of the class, which is similar to the instantiation in Verilog. Basically, if I write a full adder code, and when we instantiate this full adder into a ripple carry adder, when we try to instantiate this, when we want to use this full adder in our ripple carry adder, then we will instantiate this full adder. So basically, this object is an instance of the class. So basically, this object is an instance of the class. So in Verilog, when we need to instantiate a model, we use this full adder. Likewise, this object is also an instance of the class. So remember the definition: object is an instance of the class. We will discuss about the object in detail, but for now, remember that object is just a instance of the class, and a class is a basic building block. And coming to handle, third one, remember the points, remember the terminologies. We will discuss it more clearly. And coming to the handle, it is like a pointer to the object. So handle is a pointer to the object. It will point to the object. So handle will point towards an object. And coming to property, so these properties are variables which are declared inside a class or an object. These are variables similar to registers which are declared in a module. So we will call variables which are declared inside a class as properties. And coming to methods, so the tasks and functions which are declared inside the class are called methods. So the tasks and functions which are declared inside a class are called as methods. So these are the some of the terminologies which are used in OOPS. Now, so we'll discuss so basically this class data type is dynamic in nature. That means for every call, that is the variables will every time have different memory allocations. So different memory allocations. So every time, unlike the module which is static in nature, the classes are dynamic in nature. That is, for every time when we try to store the values inside the variables or properties, a new memory will be created. We will see this in here. So for example, this is a class called my underscore val. So this is the declaration of the class. So class followed by class name, and we can declare any variables like int a or reg b. Like this, we can declare any data type inside our class. So basically, class is a collection of different data types. We can declare any data types in our class, int a, reg b, or some variables, or we can also declare functions, and we can also declare tasks inside this class, etc. And this is end class. So this is the syntax of the class. This syntax of the class is clear, right? So basically class is a collection of different data types, like we can store int a, reg b, and we can also use functions, tasks inside this class. Is it clear? Is it clear, right?
Yeah, clear.
So basically, just I am declaring my own one class which is called my underscore var, and I am declaring int a, reg b, and I'm also declaring functions and tasks inside my class. So now some logic here and end module. When I write like this, a memory will be created for register variable A and a memory will be created for register B. So a memory will be created for register A and a memory will be created for register B, and the values which are being assigned to A and B will be stored into this particular memory locations. Is it right? Is it clear? So when A is equal to 0, it will be stored into this memory which is corresponding to the location A, and when we try to assign 1 to register A, then the previous value will be overridden and it will be stored into the same memory. So this is static in nature. So the memory is static in nature in case of Verilog, that is in module. So whenever we write when we declare register A, register B, a memory will be created for these variables like this, and when we try to store the values, it will be stored into the particular memory location, and when we try to update the value, it will override the previous values and it will be stored in the same memory location. Is it clear? This is in the case of Verilog. Now, in the case of OOPs, in case of object-oriented programming, when we declare a class and when we declare some properties, here from now I will use this word properties, which is nothing but variables. So when we declare some properties, no memory will be created here initially. So when we declare a class and declare some properties inside the class, no memory is created for variables. Initially. So remember this point, this is a very important point. So when we declare a class, here in this case class my underscore var, I'm declaring two variables or two properties, int a and reg b. So no memory is getting created for my reg a and b initially. So initially no memory is getting created for my class, unlike in the case of module, when we declare any registers, any variables, immediately the memory is getting allocated for this register A and register B. But here in this case of class, no memory is getting created. So what to do for memory to get created? So for the memory to get allocated, we will create a object. So that's why the class is a basic building block. So the class is a basic building block, or it is a just basic template. Just we have to declare some registers or properties, and no memory will be allocated for this properties, and for the memory allocation of these properties we will create a object. So when we create a object, then only memory for this property will be allocated. So then only the memory allocation for these properties will take place, and we can store some values into this properties. Then only we can store values into this properties. When no memory is getting at all created, then we cannot store any value into these properties, right? So when the memory is getting allocated for these properties, for this properties, then only we can store values into this properties. So the memory is getting created only when we create an object for this class. So is it clear? So when we create an object for the class only, then the memory is getting created for this properties, and we can store values into this properties. So is this clear? This is clear for everyone? This is a very important point. So when we write class int a in reg b, then no memory is created initially. So when we declare, when we create an object for the class only, then memory for these properties will be created, and we can store some values into this properties. So let's see how to create a object for the class. So for every class, first step for creating an object, first step is to create a handle. So we should create a handle to the class. Say for example, the class name is ex, so the class name should be present for creating the handle. So in this case it is ex followed by the name of the handle, let's say h1. So the h1 is the name of the handle, is of type ex. So the class name followed by the handle name, h1 is of type ex. So we should create a handle for the class. Basically this handle, with the help of the handle only, we can modify the values, and we can access the properties or methods in the class. So basically with the help of the handle of a class, we can access or modify the properties or methods, which is nothing but variables or functions or tasks of a class. So basically a handle is a pointer of the class. So we should create a handle for the class. So with the help of the handle only, we can access the methods. Is it clear about the handle?
Explain once more again.
So basically this handle, with the help of the handle only, we can, so basically a handle is a pointer to an object. So with the help of the handle only, we can access the elements, or we can modify the elements inside a class. Is it clear?
Yeah.
So when we create a handle, in our case it is h1, so this is our handle. It will be pointing to a memory location which is called null. So when we create a handle like this, exh1, it will be pointing to a memory location called null. So this is a handle for our class ex, so which is initially pointing to null memory location when we create a handle. So if we want to create an object, then we will use this handle h1, and we will write h1 is equal to new. So this new is called constructor. So then only the object for the class will be created. That is, memory allocation takes place for the properties and the methods inside the class. Memory allocation takes place when we create a object. So the handle which we have created previously will point to this object. Instead of pointing to null, it will point to our object. So all the variables which we have created will store the values into this memory which is being created. So this is the creation of object. So when we use the keyword new, then the object for this class will be created, that is the memory will be created for this class, and our handle will point towards this class. So for example, if we want to store the value 0 into this variable a, then we will write h1. So with the help of the handle only, we can store the values into this class, into this class. So we will, if we want to store the value of 0 into this a, then we will write h1. We should take the help of the handle dot a. So a is present inside the class ex. So the handle for ex is h1. So we'll write h1 dot a is equal to 0. Since the handle is pointing towards the object, that is the memory, so the value 0 will be get stored into the memory. So this is how the creation of object and the storing of the values inside the memory. So I will explain it one more time. So basically, initially when we create a class, then no memory will be created for the properties or methods which are declared inside the class. For memory to be created, an object should be created for that particular class. So without creating an object, we cannot store the values inside the memory, or the memory will not at all, the memory is not at all getting created if we are not creating an object for the class. So for creating an object for the class, the first step is to create the handle for the class. So wait a minute, where is that slide? Yeah, so we should create the handle to the class. The syntax for creating an handle to the class is class name, that is in our case ex, followed by the handle name, that is h1. So handle will be created, but the handle will initially point towards a null object, that is null memory. So we should use a keyword called new for creating an object to the class. So h1 is equal to new. That means h1 will now point towards an object. h1 will point to an object instead of pointing to a null. So h1 is now pointing to an object. That is, a memory will be created for this class, and we can store the values, or we can store the values of the properties inside this memory. So like this, the memory allocation takes place for a class. So this is a procedure for creating a handle and creating a object for the class. Is it clear? Now for the class ex, I'm having two integers int a and int b and ending the class. And for this, I will have one handle h1 and another handle h2. I can create multiple handle for a single class. So this is a creation of handles. So this is handle 1 and this is handle 2. So initially this will point to a null object. So handle 1 will point to null and handle 2 will be pointing to null. So I can create two objects. So h1 is equal to new. So one separate memory will be created, and when I write h2 is equal to new, another memory like this will be created. So there will be two memories. So there will be two memory allocations for my class like this when I create two objects. Is it clear? So this is the creation of handles and objects and the syntax for class and handles in OOPs. So if you are having any doubt, you can ask. So this is